Okay, here we go. So we're going to walk through the answer key to quiz number 1. So this was the problem you were given. You have a nitrile, and we're doing acid catalysis with acidic water, and we're turning that into an amide. Now, if you want, what would be really good is if you go back and review your notes from the alkyne chapter with triple bonds. You'll see that we did a reaction very similar to this, where we had a triple bond, we treated it with acidic water, and we ended up with the hydrolysis of the triple bond, making an enol, and the enol tautomerized to the keto form, which in that case was a ketone. If you go back and look at those notes, you'll see that the steps in the mechanism for this problem are going to be almost exactly the same as the mechanism that we did for the acid catalyzed hydrolysis of a triple bond to make a ketone, except now we're going to do it on a nitrile. So let's get started. First thing we want to do is we always want to check our pH, and when we look at the pH right here, we say, okay, over the arrow, we have acidic pH. That means let's keep everything at neutral charges or positive charges, but no negative charges anywhere throughout the mechanism, okay? So I'm going to put a plus sign here on the top right-hand side and keep track of that as my, my charge check to make sure that I don't violate that. So here we go. The first step is going to be, you're going to take the lone pair of electrons on the nitrogen, and that's going to be your nucleophile, and that's going to go after the proton as the electrophile, pick up the proton. And that was a step that I was very, very happy that probably the large majority of the students in the class did, in fact, choose that as the first step, where the lone pair go after the H+. Some students actually did this. Let me erase this. Some students actually said, for the first step, we're going to go from here to there to pick up the proton. Now, that would be true if we were doing this on a triple bond where both ends of that triple bond were a carbon. But here we've got a nitrogen on one end and a carbon on the other end, and that nitrogen has a lone pair of electrons on it. And if you remember your atomic orbital and molecular orbital theories where you have bonding orbitals and then non-bonding orbitals and then anti-bonding orbitals, well, the lone pair of electrons on the nitrogen are the non-bonding, right? So they're in the middle here. This is your non-bonding electrons, which are higher energy than your bonding electrons. So you have a choice. You could use the bonding electrons in the triple bond to be your nucleophile, or you could use your non-bonding electrons to be the nucleophile. green, okay? Okay, so here we go. So we have nucleophile goes after electrophile. 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 Nucleophile, electrophile. Nucleophile, electrophile. Nucleophile, electrophile. Nucleophile, electrophile. And that gets you to find a product. So every step is one that should be doable. It's really just an organization of steps we've seen previously in other reactions, other reaction mechanisms. Reorder them around a little bit, and you come up with this mechanism here. If you want to give this one a name, if you want to look it up, like say Wikipedia, the name of this would be called acid catalyzed hydrolysis of a nitrile to an amide. Okay, so if you have any questions about that, shoot me an email, and we can chat about it online, or we'll be in class and we can talk about this in class briefly at the start of class tomorrow night.